Today we're going to determine whether a problem requires us to combine like terms or to use properties of exponents. Combining like terms involves sums and differences. Properties of exponents involve products and quotients. An example of an expression that requires us to combine like terms would be 6x plus x plus x squared. This expression requires us to combine like terms because of this plus and this plus here. Another expression that requires us to combine like terms would be x squared minus 3x squared. This requires combining like terms because of this minus sign. You could also have a combination of a difference and a sum. This expression also requires us to combine like terms. Some expressions that require us to use properties of exponents could be 6x times x squared. This requires properties of exponents because we have products, and this will require us to expand and simplify. Another possible expression that would require properties of exponents could be x squared divided by 3x squared. This would require properties of exponents because we have a quotient. And finally, if we had a quotient, that would also require properties of exponents because we don't have a sum or difference here. Now we're going to determine whether these four examples require us to combine like terms or to use properties of exponents when we are simplifying. Take the opportunity now to decide which problems require which tools. Number 1 involves differences and sums. So number 1 will require us to combine like terms. Number 2, this will involve expanding and simplifying. That is a problem that requires properties of exponents. Number 3, x squared plus 3x squared. This problem will require us to combine like terms. And finally, number 4, x squared times 3x, all of that squared, that's definitely going to require properties of exponents. That will require us to expand and simplify. So let's figure out what our like terms are. This term has an x attached to it, and this term has an x. So we would combine 5x and positive x. 5x plus x. Well, remember that if there's not a number written in front of the x, we know that that's the same as 1x because 1 times x is x. So this is the same as 5x plus 1x, and that results in 6x. We also have an integer, a -8, and a -3, and we can combine those numbers. -8 minus 3, -11. Is there anything else we can combine? No, because this term has an x and this term is just a number. Those are not like terms. Let's skip to number 3 and combine like terms. Are x squared and 3x squared, are those like terms? Yes, they are. They both have an x to the power of 2. Same variable, same exponent. As we discussed before, the number that is in front of this x squared is simply 1. So when we add 1x squared plus 3x squared, we get 4x squared. The power does not change when we combine like terms. The power changes when we apply properties of exponents. Number 2, this one will require properties of exponents. The base of the exponent is the thing that's going to be multiplied by itself. The base of our exponent here is this product 5x, and that will be multiplied by itself 3 times. That's what the exponent indicates. So I'm going to write 5x times itself 3 times. 5x times 5x times 5x to expand. Now I'm going to simplify. And remember that multiplication is commutative, meaning 2 times 3 is the same as 3 times 2. So I can actually adjust the order if you want to make it a little clearer for yourself visually. I'm going to put all the numbers together. So 5 times 5 times 5. I could use parentheses, but I'm going to use the dot. They mean the same, so it's okay. X times x times x. And that simplifies to be, all right, let's evaluate what is 5 times 5 times 5. Well, 5 times 5 is 25, and 25 times 5, 25, I like to think of it like money, so that's a quarter. And if I have 5 quarters, I would have $1.25. So 5 times 25 would be 125. This simplifies to be x to the power of 3 because it's x times itself 3 times. Number 4 also requires us to use properties of exponents. And when we expand, there will be several things that we are going to expand. First of all, x squared. This is an x times an x. That's going to be multiplied by this product. Okay, so I have an exponent of 2 right here. And what is the base of the exponent of 2? It's this product 3x. 3x needs to be multiplied by itself 2 times. So I will take the product 3x and write it multiplied 2 times because it's 3x times itself. To make it easier for me to visualize, I'm going to write the numbers in the front all together, group them together, and then group my x's. So I have a 3 times 3 times x times x times x times x. I will evaluate what is 3 times 3. That's 9. And then write this expansion as a single power, x to the power of 4. This is how we use properties of exponents and how we combine like terms. Remember that combining like terms involves sums and differences, whereas properties of exponents involves products and quotients. Want a challenge? Try this one. Check in with your teacher to see if your answer for number 5 is correct.